Have you ever stopped to wonder how an AI like ChatGPT actually gets you? I mean, it doesn't understand words like we do. It only knows numbers. Well, behind it all, there's this secret mathematical engine that translates our messy human world into pure, clean logic. And today, we are pulling back the curtain on that engine, embeddings. So yeah, this is the central puzzle, right? On one hand, you've got the rich, nuanced, kind of chaotic world of human language, and on the other, you have the cold, hard logic of computer code. How in the world do you build a bridge between those two? Well, the answer is surprisingly brilliant.
So let's get into it. Section 1, from words to numbers. That bridge is built using a really clever mathematical translation. It's a process that takes something we totally get, words, and turns them into something a machine can process, just long lists of numbers.
And this whole process, it has a name. It's called an embedding. At its core, an embedding just takes any piece of text, could be a single word, could be a whole book, and it converts it into this special list of numbers called a vector. But here's the key. It's not a random list. It's a carefully crafted numerical code that actually captures the text's real meaning.
You know, the best way to wrap your head around this is to think of it like a fingerprint. Just like your fingerprint is a unique identifier for you, an embedding is a unique mathematical meaning fingerprint for a piece of text. No two different meanings are going to have the exact same fingerprint.
In this right here shows that transformation perfectly. On the left, a simple sentence we all understand. On the right, that's what the AI sees, a long, abstract list of numbers. Now, those specific decimals don't matter to us, but for the machine, that precise sequence of numbers is the meaning of a cute cat asleep. Okay, so the AI has all these unique numerical fingerprints for, well, everything. But how does that actually lead to understanding? The real magic isn't just in creating these fingerprints, it's all about how they're organized.
Each one of those fingerprints becomes a coordinate, a specific point on this huge, multi-dimensional map. And this map has a technical name. It's called a vector space. You can kind of think of it like a massive library of every possible meaning, where every single word and sentence has its own precise location.
Now, this entire giant map is governed by one simple but incredibly powerful rule. Distance is meaning. If two ideas or concepts have similar meanings, the points on the map are going to be close together. And if they're totally unrelated, they'll be miles apart. It's that simple. Distance equals similarity. The absolute best way to picture this is to think of Google Maps. In any city, right, you'll find all the restaurants clustered together in one area, while parks and houses are somewhere else. This vector space works exactly the same way. All the words related to food, like pizza and burger, they're all going to be in one neighborhood of the map, far, far away from the technology neighborhood. This table makes it super clear. In this map of meaning, words like cat, dog, and lion are all mathematical next-door neighbors. But the word car, that's in a completely different zip code. The AI doesn't know what a cat is, not really, but it knows from the numbers that a cat is way more like a dog than it is like a car.
Okay, so this is all fascinating theory, but where does it actually show up? Well, it turns out this map of meaning is the invisible engine powering a ton of the digital services you use every single day.
Seriously, it's everywhere. From the way Google seems to read your mind, to how Netflix and YouTube just know exactly what you want to watch next. That's embeddings at work. They help your email filter out spam, they power modern chatbots, and they even help detect financial fraud by spotting weird patterns. Let's take a look at search. A basic keyword search is super literal. If you type affordable phones, it looks for exactly those words. But a semantic search, which is powered by embeddings, understands your intent. It knows that the meaning fingerprint for affordable phones is super close to budget smartphones or low-cost mobile devices, so it gives you way better, more relevant results. This is also the secret sauce behind those really accurate chatbots that use a technique called RAG. So when you ask a question, first it gets turned into its number fingerprint. Then the system zips through a huge database to find documents with the closest matching fingerprints. And finally, it feeds all that relevant info to the language model to create an answer that's actually grounded in facts. All right, so when you put all this together, you start to see that embeddings aren't just some clever programming trick. They're actually a fundamental breakthrough in how machines can finally interact with human knowledge. I mean, this chart really says it all. Without embeddings, a machine's ability to understand language is, well, it's pretty limited. It's super literal. But with embeddings, that ability just skyrockets. Suddenly, the machine can grasp context, nuance, and the relationships between ideas, all through the simple math of distance.
And ultimately, that's what they are. They are the Rosetta Stone for AI. They provide that critical translation layer that allows the logical, structured mind of a computer to finally make sense of our beautifully chaotic world of human communication.
So the next time you get a perfect recommendation on YouTube, or a search engine seems to just know what you're thinking, you'll know why. You can thank embeddings. This isn't just abstract computer science. It's the invisible, mathematical choreographer quietly organizing the world's information behind the scenes of your daily life.
Now, embeddings are just one piece of this incredible AI puzzle. They are the foundation, for sure, but there's so much more to explore, from things like attention mechanisms to transformers. So what part of this fascinating world should we break down in our next explainer? Let us know what you think.